welcome to my ELTEC 208 final project, the Joule Thief. It's a long video, so I'm not going to go over the components here. If you want to, you can pause and read them and write them down. I will put them in the description of the video.
Alright guys, this is my ELTEC 208 final project. I'm going to keep it short and sweet. We've got our load, which is 3 white LEDs, 3 volts each. They're connected in parallel though to the transistor in the circuit. We got this transformer, and we got this 1.5 volt battery. And I know what you're thinking, how are we going to light a 3 volt LED with a 1.5 volt battery? And you're right, it doesn't work. When I press this button, all this button does is connect the power source, the voltage source, to the load, being the 3 white LEDs in parallel. And that 1.5 volts isn't going to light the LEDs up. But this button right here connects the base of the transistor to the transformer and allows the transistor and the transformer to do this sort of dance that allows for this to happen. As you can see, the LEDs are lighting up. They're lighting pretty bright too. Um, Depending on the angle you're looking at an LED, it looks brighter. But trust me, they're all lighting at the same brightness. As I move that around, hopefully that becomes apparent. Um, can't light anymore because I just dropped it, and this little battery holder I made is so finicky. There we go. But yeah, and to make things even weirder, if we actually take the voltage source out, and we're going to go ahead and measure the exact amount of volts in this battery to show you that it's not a fake battery or some kind of magic battery that has more volts than it actually should. Wait a minute. This thing has less volts than it should. This is a dead battery. So not only was a 1.5 volt battery going to be able to light this 3 volt LED, but a 0.6 volt battery was able to light the LED, and 3 in parallel. So that means there was enough current to light them all up to the brilliance that they had, which goes to show you the power of a Joule thief.
Okay, here's the Joule Thief schematic. Real quickly, we'll go over the components and what they do. Switches open and close the circuit. An open circuit, current cannot pass through it. A closed circuit, current can pass through it. We've got this voltage source, 6.632 volt AAA battery. Voltage source needs to be DC, preferably a dead battery, because this circuit, its main purpose is to extract the last bit of energy out of something that would ordinarily not be able to power anything else, like a dead battery. So it doesn't really make sense to hook up a fully charged battery or hook this up to an outlet or anything. Dead batteries work the best for Joule thieves. We got this 1K ohm resistor. That 1K ohm resistor is going to do a little work in the form of heat dissipation. So volts and currents are going to run through it, and it's going to take a little bit of that pressure off of the load, so the load doesn't get damaged. Our load being 3 volt white LEDs. LED stands for light emitting diode, which means when current is or when 3 volts is running through these diodes, they will emit a white light. These diodes are forward biased, meaning that current will only run from the positive side to the negative side. The positive side is called the anode, that is the base of the triangle. The negative side is called the cathode, and that is denoted by this line at the tip of the triangle. Current will be flowing in the direction the triangle is pointing. Um, Diodes are made out of 2 semiconducting materials: N-type materials, standing for negative type, which is the cathode, and P-type material, which is the positive side, which is the anode. And that's important to know when we're describing NPN transistors, because an NPN transistor is just like a diode, meaning that being that it's forward bias, current will only run out the emitter. Current will not flow through and out the collector or out the base. Current can only flow into the base and into the collector, and they will both flow out the emitter. When you first put current through a transistor, though, the collector avenue is shut almost by like a gate. And imagine to get in that gate, we need zero point 0.7 volts running through the base and the emitter. So the collector gate will quickly open up, usually, but not right away. So after that 0.7 volts happens or is running through the transistor, Collector gate will open up, and current will be allowed to flow from the collector to the emitter and the base to the emitter at the same time. When that zero point 0.7 volts is no longer met, the collector gate will shut, and that is what an NPN transistor does. Um, that leaves us with the transformer. This is a toroid transformer. It just basically describes this type of transformer with two insulated wires wrapped around a donut-shaped iron powdered core. These wires are wrapped in parallel around the core, but connected into the circuit in such a way that if we ran current through them, those currents would be flowing in opposite directions. And you can see that if you follow the wires. The black wire is hooked up and wrapping around the right side of the toroid, but it's wrapping around and coming out of the left side. The the red wire is doing the opposite. It's wrapping around the left side and coming out of the right side of the toroid. Um, the black wire is hooked up to the base of the transistor, and the red wire is hooked up to the collector. They're the transformers wound 1 to 1, meaning if we're running 10 volts through the primary inductor, when it induces voltage into the secondary inductor, it's going to be 10 volts as well. With the coils 180 degrees out of phase from each other, this just means what I was saying about the current, that current flows in opposite direction when we have current running through both of them. What a transformer basically does is it allows for the transfer of voltage via magnetic field. So when current is changing, when you pass current through the first inductor in the transformer, that current is going to induce a magnetic field in the iron core, and that magnetic field is going to induce a back electromagnetic force in the secondary coil. Normally, that voltage would be opposing the secondary coil, but because if we run current through these wires, and that current would be running in opposite direction, while the magnetic field is growing, that current is actually going to be providing extra volts for the wire that is in parallel with. So, because current is flowing in opposite direction between the wires, the opposing voltage will actually add voltage to the secondary coil or the primary coil, because they can both have induced voltage from each other. When the magnetic field is collapsing, the magnetic field will be collapsing in the opposite direction it was growing, which means due to Lenz's law, or Lenz's law tells us that whatever force is creating inducing an electromagnetic force, that electromagnetic force will be flowing in an opposing direction that it's from what it's being induced by. So when the magnetic field is collapsing, it's moving in the opposite direction, so the induced voltage will be moving in the opposite direction. So that induced voltage, when the magnetic field is collapsing, will provide opposing voltage to the to the wire it's in parallel with. Sounds really complicated, but long story short, when current is changing, magnetic field is growing. When the magnetic field is growing, it is inducing voltage into the other wire, or the other coil, or the other inductor, whatever we want to call it. And because these coils are connected to the circuit in such a way that current is opposite, that opposing voltage is actually adding voltage while the magnetic field is growing. And while the magnetic field is collapsing, that induced voltage will be opposing voltage. Um, and that is what a transformer does in a nutshell. So how does a Joule thief work? Well, let's look at it from the point of view of an electron. Um, Joule thieves run in conventional current. So an electron is going to start off by going through the positive side of the voltage source. So it's going to come out of the positive side of the voltage source, and it's got three paths it can take. One through the base in the emitter, one through the collector in the emitter, and one through the load. The collector gate is closed right now, so we cannot take that path. The load takes 3 volts, and we only have 0.6, so we can't take that path either. So the electron is going to take the path between the base and the emitter, and then back to the negative side of the voltage source. So through the black wire, around the transformer, through the resistor, through the base and the emitter, back to the voltage source. That's the first path. Soon after the electrons take that path, the collector gate will start opening. And once the collector gate starts opening, the electrons can now take a second path through the collector and the emitter. And because the electrons are taking a path through the collector emitter, that means current is now flowing through both the red and the black wire. And because current is now growing between uh, the current is growing in the black and the red wire, the black and the red wire are inducing a magnetic voltage or a magnetic field, and that magnetic field is inducing opposing voltage in each other's inductors. And like I said before, while it's growing, that opposing voltage will actually apply voltage to the uh, wire in parallel. And so that means that this black wire is actually getting more voltage while the collector gate is opening. And this causes a chain reaction. That means more voltage is going through the base and collector, which is opening the base and the emitter, which is opening the collector even more, which means even more voltage is running through the red wire, which means that magnetic field through the red wire is inducing even more voltage into the black wire, which has an effect that causes the collector gate to open extremely quickly. Um, but even when the collector gate is fully open, we still do not have enough voltage to run um, our load. The lights are still not lit up yet, and that happens when everything falls apart, which pretty much is what happens next. Um, the iron core is going to become fully saturated, meaning that it can no longer store any more electrons in the magnetic field that it has induced. Current will stabilize, and because current stabilizes, um, that extra uh, induced voltage from the magnetic field growing will no longer be there. So this black wire is going to lose that nice extra voltage it was getting from that uh, back EMF from the other inductor. And that loss in voltage is going to cause the collector gate to start closing a little bit. And because the collector gate starts closing a little bit, the current through the red wire can no longer support its magnetic field. Its magnetic field starts collapsing. And remember what we talked about? We said that when the magnetic field collapses, the induced voltage that it provides to the other inductor will now be opposing voltage. So that the red wire's magnetic field starts collapsing, that induced voltage in that uh, black wire is now opposing voltage, which means there's even less voltage running through the base and the emitter, which means the collector gate shuts even faster, which reduces the current in the red wire, which causes a chain reaction in the opposite direction, which causes the collector door to slam shut. And when the collector door slams shut, the red wire will expel all the energy that it has collected in its magnetic field in an attempt to keep current running in the same way that it was before the collector shut. And because the collector shut so quickly, it's going to expel that energy from its magnetic force just as quick into the circuit. And because it cannot go backwards, this is a forward bias circuit, and it cannot go through the collector anymore, that voltage spike has to go through the 3-volt white LEDs. And that voltage spike is enough to light the LEDs to full brilliance. It meets the 20 milliamp uh, requirement, and it meets the 3-volt requirement, all three of them. But that magnetic field that was around the red wire only has so much stored energy, and when that runs out, there will be no more opposing voltage to the black wire. The black wire will gain some of that voltage back once that magnetic field has disappeared, and it will start to open the collector gate again, and the process will start all over again. And that is what a Joule thief does. It takes a slow and steady voltage, a direct current voltage, and outputs large spikes of voltage from it. And it happens very quickly, so the lights appear to be on, but they're really just turning on and off about 20,000 times a second. Hope you enjoyed the Joule Thief project. We're going to watch a little animation on the current, and I will explain some of my mistakes and why this was so difficult. Um, this is a little animation of how the current works in Joule Thief. It's just missing a few things. It only has one LED, and there's no switches there. I had a lot of struggles during this project, mainly learning exactly how a Joule Thief works. It's a little simple circuit, but it's very complicated. And if I was going to do this project over again, I'd probably choose a little something a little simpler. Um, I I've redrawn the schematic probably 80 times because every time I would start a video describing the schematic, I would realize something was drawn wrong or something wasn't in the right place or there was a short in the circuit that didn't make sense. So I had to go back and revise it and relabel it. Took me a long time to be able to uh, articulate what each and every component does and what it does in the circuit. My inspiration for doing this project came from my girlfriend's father. He's an electrical engineer, and he suggested the Joule thief. And when I looked it up, there was pretty much all the components in the in the kit that we got. You could actually use a nail as the transformer by wrapping two wires around the nail and using that instead of a toroid, and it'll work just fine as well. Um, yeah, I'm gonna follow this animation up with just a few pictures of my failed other projects. Pretty much, I pretty much redid this project like 3 or 4 times now. So yeah, hope you enjoyed my project. Thank you.